You find the plane of your dreams in a secondhand store nestled between a box of old shoe repair tools and a bag of petrified blackjack chewing gum. It's seen some abuse, but it's not too rusty and it's all there. You think we can get this back into working condition? Come on, we can do better than that. In a previous video, I wrestled with a bench plane that had been so poorly made, I had to completely remanufacture it just to get it to cut wood. I did some plane tuning, but really I had my hands full trying to turn this disaster into something resembling a mediocre tool that I really never got down to the nuts and bolts. This time, I'd like to take a good tool and see if I can get it to sing and dance. Travis, I'm sure, will provide the appropriate music. This is a Stanley No. 5 jack plane, type 14, made sometime in 1929 or 1930. We've cleaned it up, wire brushed it to get rid of the rust, but we haven't yet tuned it. In fact, I don't think this has ever been properly tuned. There's no evidence even that the bottom has been flattened. So, let's take it apart and see what we've got. The lever cap is in good shape. The nickel plating is not chipped or worn. The Chipbreaker was badly rusted, bad enough to develop pits. The same is true of the plane iron, but both of them are still usable. The frog is all there and has a nice big brass wheel for adjusting the depth of cut. But at some point, someone has sprayed the frog with paint, covering up the bearing surfaces where the frog supports the plane iron. The paint will have to go. By the way, this is not called a frog because it looks like a frog. This looks nothing like a frog. It's called a frog because the indentation in the bottom reminded craftsmen of a similar structure in a horse's hoof, which is also called a frog. This may have come from an old German word, frosch, which describes the bottom of a hoof. The front knob and the rear tote are in great shape. That's a relief because these are made out of rosewood and they would be costly to replace. Many woodworking suppliers offer replacement handles for between $30 and $60 US, with rosewood replacements on the high end of that spread. And that leaves us with the sole, which is in phenomenal shape. It's stained, so there may have been a little rust at one point, but there's no pitting. And you can still see the mill marks from the initial machining, so it's never been lapped flat. That's why I believe this plane was never properly tuned. Also notice that the sole is corrugated, as opposed to this Stanley bench plane, which has a smooth sole. Corrugations reduce the friction between the wood and the sole, requiring less effort to plane. They were once preferred for scrub planes, which are tuned and adjusted to quickly remove wood. I used a scrub plane in our video on bandsaw lumbering to flatten the whole side of a log. My grandfather liked these corrugated planes because they were easy to lubricate. He'd take a candle or a piece of paraffin and rub them on the sole across the corrugations, filling them with wax. The wax would slowly melt due to the friction, feeding it onto the sole. This reduced his effort while he worked. While we've got this plane apart, let me show you how an all-metal plane works. The frog, which is secured in the sole, holds the plane iron at a fixed angle to the wood. This angle is usually 45 degrees, but there are low-angle bench planes which hold the iron at a much reduced angle. Just ahead of the frog, there is an opening in the sole called the mouth. The leading edge of the mouth compresses the wood just ahead of the cut. This prevents the plane iron from lifting and splitting the wood, like this chisel plane, which has no mouth, is wont to do. See that? The mouth ensures a smooth cut. As the iron cuts the wood, the chips slide up the iron and encounter the Chipbreaker. The Chipbreaker pushes the chip forward, bending and snapping the cellulose fibers as they enter the mouth and rolling them up into the wood curls that we all love to cut. This makes it infinitely easier to keep the chips from clogging the mouth. Use this molding plane for a few minutes and you'll see exactly what I mean. These parts must work together to form a solid assembly. If the plane iron is not properly supported, It may bend backwards ever so slightly as it encounters the wood and then suddenly spring forward as the wood gives way. It may do this several times in a single second, creating what is called chatter and leaving a rough cut. If you're wondering what you get in an expensive model that you can't get in a cheaper one, it's good machining and thicker parts. These work together to form a stable, solid bed so that the plane iron can make a good cut. The first step in tuning a plane is to flatten the sole. You want the area around the mouth to contact the wood at the same time and with the same amount of pressure as the rest of the sole. If the mouth rests below the sole, the plane will rock and you won't get an even cut. If the mouth is above the sole, the mouth won't compress the wood ahead of the cut and the cut will be rough. Now, supposedly, this plane was machined flat when it was made. However, castings have a way of changing shape and shrinking slightly months and months after they're poured. More importantly, it was not machined with all the pieces and parts attached, and that makes a difference. I'm going to start lapping with 180 grit. Attach some wet dry sandpaper to a flat surface. You can use melamine, a cutout from a laminate-covered countertop, or even a piece of glass. For a long time, I used a granite pastry stone, but now I have this old planer bed that I use as a lapping plate. Reassemble your plane. The sole should be under the same stresses from the frog and the other components as it is when you're planing. Using a marker, make some marks across the sole from side to side. This will help you see the high spots and the low spots. When the marks completely disappear, the sole is flat. Begin lapping, pushing the plane back and forth across the sandpaper. Add a little water to float away the iron filings or the swarf as you work. And here's the sole, completely flat. It has a consistent shine and there are no mill marks. Now most people stop here, but I like to go on to 320 and 600 grits. The smoother the sole, the easier it will be to push across the wood. Besides, once you get past 180 grit, successive grits go much faster because the sole is flat. Before starting with each grit, mark the bottom and continue lapping until the marks disappear or until the entire sole has a consistent shine. Once the sole is flat, inspect the area around the mouth. If the edges are ragged or rounded over, take a smooth mill file and square the leading edge, like so. Some craftsmen also like to file a bevel in the trailing edge, like this. But I've rarely felt this is necessary except on scrub planes where a wide mouth comes in handy. While you've got the file out, lightly bevel or round over the edges of the sole, especially at the front or toe. This will prevent the sole from scraping or digging into the wood as you plane. Inspect the frog and test it with a straight edge to make sure it's flat. This part almost never needs work, but the bozo who spray painted this covered a hard surface, iron, with a softer surface, paint, and now we can't be sure that the frog will properly bed the iron. I mixed up some toluene, acetone, and denatured alcohol, and I painted it on the bedding surface of the frog to soften the paint. Then I scraped off as much of the paint as I could with a scraper. There was still a lot of paint left, which I could have removed with a wire brush, but I suspected that this frog was slightly out of true. It was hard to tell with all the paint. So I made a special lapping plate from melamine just for the frog. The groove in the plate accommodates the lateral position adjuster where it protrudes above the frog's surface. I was able to rotate the depth of cut adjuster so it did not interfere with the lapping. As I've said, it's very rare to find a frog on a reputable brand that needs this kind of attention. In all the planes that I've ever tuned, this is only the second time that I've ever had to deal with this problem. But at least now you know what to do should you encounter a warped frog. The plane iron is mounted on the frog with bevel down. There are several reasons why this is important to consider. First, the angle at which the frog beds the iron is the cutting angle, the angle at which the cutting edge meets the wood. If you were to turn the iron over, the cutting angle would be equal to the frog angle plus the tool angle, the angle between the bevel and the back of the iron. This would make the cutting angle much too steep, more suited for scraping than cutting. And second, what would normally be considered the front of the plane iron is actually bedded down on the frog. When you sharpen a chisel, you flatten the back and then grind the bevel. Ideally, to sharpen a plane iron, you should flatten both the front and the back. The back to get a good straight cutting edge, and the front to get a good engagement with the frog. But here's the problem. When you flatten a surface on the plane iron, you make it thinner. The thinner the plane iron gets, the more prone it is to chatter. If you flatten both the front and the back, you could be making the plane iron too thin. What I usually do is give the front of the iron a few swipes across the abrasive, making sure that it's relatively flat and trying not to remove a great deal of steel. Then I flatten the back completely, but just in the area of the cutting edge. As you grind it, press down firmly near the bevel, but not so much further up the iron. Once the surfaces are flat, grind the bevel. Normally, plane irons are sharpened at 25 degrees. But you may want to make a slightly larger angle if you plane mostly hardwoods. The larger bevel puts more metal behind the cutting edge, buttressing so that the edge stands up better to harder stock. I sharpen my irons at 27 degrees, and I know craftsmen who prefer 30 degrees because they work mostly with maple and birch. I'm using sandpaper and the same planer bed to do the sharpening as I did the lapping. If the iron is very dull, and this is, I start with 180 or even 120 grit, and then I work my way up to 1000. If it just needs a touch-up, I start with 320 or 400 grit. I'm using a jig to maintain a precise angle. If you'd like to make this jig, the plans are in my sharpening book. There's a link to the book hovering in the upper right-hand corner. You might also like to take a look at our sandpaper sharpening video. There's a link to that at the end of this video. For each grit, I grind the bevel until it has a consistent shine all across the surface. Then, without taking it out of the jig, I turn it over and make a couple of strokes on the back. This removes the burr that develops when you grind. Finish up by stropping the bevel on a piece of paper on which you've rubbed some polishing compound, such as chromium oxide, the green stuff that you see here. Draw the plane iron backwards across the paper until you can see your reflection in the bevel. Now, some folks prefer a secondary bevel at the very tip of the edge. This tiny bevel enlarges the angle at the tip, making it more durable. To do this, put a few layers of paper or some poster board on the sharpening surface. Place the jig so that just the wheels are on the paper, changing the angle ever so slightly. Draw the bevel back along the fine sandpaper, 600 grit or 1000 grit. Once or twice, that's all it takes. You also may want to sharpen the plane iron so that it has a slight camber or arch from side to side. This prevents the sharp corners from biting into the wood and leaving little steps or lines. This is very simple to do. Put 2 fingers on the back of the plane iron as you sharpen the bevel. Place 1 finger on the right corner and the other finger on the left corner. As you sharpen, count your strokes. Make 20 strokes applying more pressure with your right finger, then make another 20 applying more pressure with your left finger. Repeat until a camber develops. And while we're talking about plane irons, I want to let you in on a little secret if you don't already know it. One of the best ways to boost the performance of an older plane is to replace the plane iron that came with it with a thicker one. I prefer Hawk blades, H-O-C-K. They are about 20% thicker than a normal blade, made from a fine-grained high-carbon steel and tempered to be slightly harder than an ordinary blade. The thickness and the hardness reduces the chatter, making a smoother cut. They are also dead flat on both the front and the back. You don't have to worry about flattening either surface. They are also sharp enough to shave with. Really. Both Travis and I tried this, and there are hairs all over the shop. Now, I know this sounds like a commercial, but we have no agreement with Hawk Tools. It's just a great product that I've relied upon for 40 years, and I want you to know about it. I'd love to shake Ron Hawk's hands as soon as the Band-Aids come off. The leading edge of the Chipbreaker must press firmly against the plane iron so there are no gaps, none, between the two. To make sure that this happens, I joint the bottom edge of the Chipbreaker on my lapping plate, beveling it slightly to give it a sharp, straight edge. Then I attach the Chipbreaker to the plane iron and test the fit with the thinnest feeler gauge I have in my toolkit to make sure that not even a piece of paper can sneak under the breaker. To mount the breaker on the iron, install the machine screw that holds them together. Insert the screw in the round opening with the breaker and the iron crossed, and then rotate the breaker into place well behind the cutting edge. Snink the Chipbreaker up close to the cutting edge, and then tighten it in place. Remember that the Chipbreaker actually sneaks closer to the edge as you do this. How close is close enough? Well, I usually aim for about a 32nd of an inch or half a millimeter. Remember, you can always adjust it if you're not getting the curls that you want. For the smoothest cut possible, you must adjust the mouth so that it's just a little wider than the thickness of the shavings. To do this, you must slide the frog back and forth. Just how you move the frog will depend upon your plane. Older planes, such as this, have frogs which rest on several legs that contact the sole. They are held in place with 2 machine screws. Loosen the screws and you can slide the frog back and forth using the mouth adjustment screw in the sole, just beneath the frog. Let's do this with the plane iron attached. Make sure that the frog mounting screws are snug, but not so tight that you can't easily move the frog back and forth. Put the plane iron and the Chipbreaker assembly in place. The large screw must face down. It fits the recess in the frog. Put the lever cap in place and lock down the lever to secure the iron. You may have to adjust the machine screw that holds the cap in place if the cap is too loose or if the lever is too hard to lock down. Remember, you want the iron to be secure, but not locked down so tight that you can't adjust the depth of cut or the lateral position. Adjust the depth of cut so the blade protrudes ever so slightly from the bottom of the sole. Using a blade screwdriver, turn the frog adjustment screw to close down the mouth or open it up, whatever you think you need. If you don't get it right, you can always readjust. When you've got the mouth where you want it, retract the plane iron, loosen the lever cap, remove the plane iron, and tighten down the screws that hold the frog to the sole. Let's put everything back where we had it. The plane has to be completely reassembled for this next part. We're going to adjust the depth of cut, the lateral position of the iron, and then we'll make a few test cuts. Turn the plane over and hold it with the toe near your nose. Sight down the sole and adjust the depth of cut so that the cutting edge protrudes slightly from the mouth. Using the lateral position lever, adjust the iron so the edge protrudes evenly all along the mouth. If the edge is cambered, there should be a little more showing in the middle than at the sides. Once the lateral position is where you want it, retract the plane iron into the mouth. I think we're ready to make a cut. Clamp a piece of scrap wood in your vise or secure it to your workbench. Then, with the plane iron still retracted, begin planing. As you're planing, slowly advance the iron until the plane just begins to shave the wood. If you want to make deeper cuts, continue to advance the iron. Always set the depth of cut by advancing the iron. If you need to reduce the depth of cut, retract the iron to make the cut shallower than you want, then advance the iron to the proper depth of cut. This is important. You always need to advance an iron to the desired depth. Every mechanical system has some slop or lash in it. Otherwise, you wouldn't be able to turn a screw or slide a miter gauge in a slot. But sometimes this lash can open up a gap between 2 parts that really need to be touching. When you retract the iron, the yoke pulls away from the leading edge of the cutout in the Chipbreaker and presses against the trailing edge. If I were to make a cut right now with a gap between the yoke and the leading edge of the cutout, the wood would push the iron back up the frog. The depth of cut would get shallower and shallower as I work. And we can avoid that by always making sure that we advance the iron into the desired depth of cut. Now, we need to make one more check. We need to make sure that the lateral position is correctly set. To do that, we first make a pass with the right side of the plane on the wood, and then a second pass with the left side on the wood. If the two shavings are the same thickness, then the lateral position of the plane iron is set correctly. There's one more adjustment that you can make while using the plane, and you can do this without moving a single part. As I said, the frog holds the plane iron at a fixed angle, and this angle is 45 degrees while the frog is moving straight ahead. But if you turn the plane to the right or left and push it forward in the same direction with the iron canted right or left, the cutting angle is reduced. This adjustment is extremely useful if you're working with hardwoods or woods that are difficult to work by hand. Just turn the plane to the right or left to reduce the cutting angle and then push forward. The cut will be much easier. One more thing before we can pronounce this plane tuned. We need to retract the blade and then wax and buff the sole. Now, some of you who live in humid environments may want to disassemble the plane and wax and buff everything. That will help prevent rust. But waxing and buffing the sole lubricates the plane, helps it glide over the wood. Okay, let's see how we did. Yeah, I'd say that's pretty close to singing and dancing. My work here is done.